Okay, so today's lesson is section 8.1. We're covering exponents. Your next unit, guys, you will have some in chapter 7 on your next test, and you're testing over 8.1, 2, and 3. There's 3 sections on your next test. All right, so we're covering those 3 sections this week, and then you'll test next week. All right, so here's some important information for 8.1. What is a power? Well, that's the product of repeated factors. What is an exponent? Well, an exponent tells me how many times I'm multiplying the base by itself. So we actually just talked about that in our quick review. It's not 8 to the third power is 8 times 3. It tells me how many times to repeatedly multiply my base. Okay? Now, this last statement, what is that symbol on the last statement that I just highlighted? That is parentheses, and they matter when you have a negative base. So I'm going to show you briefly what I'm talking about here. We have negative 2 to the third power, and we have negative 2 to the third power, okay? And I'm going to show you the difference between them. Let me just spread them out a little bit more. So when the base is negative and it's in parentheses, it means that the base is negative, meaning that it's negative 2 times negative 2 times negative 2. All right, and I'm going to take a quick time out. Why do I not have my first number in parentheses? I actually had this question last hour. I thought it was a really good question. Why is it not in parentheses? Okay, what do the parentheses actually do, Sherelle?
It blocks off the negative from the multiplication.
Yes, there's a double sign on the next terms. Times a negative, times a negative. Well, the first term only has a negative, so technically it does not have to be in parentheses. However, if you're kind of symmetrical and you like everything to kind of be the same, you can put it in parentheses and that would be fine. All right, so what the parentheses tell me is that it's negative 2 times itself 3 times, which is what's negative 2 times negative 2 times negative 2? Negative 8. We just kind of established that in our short review at the beginning of the lesson. But when the base is negative and it is not in parentheses, it means that there is a negative, okay, but it's not connected to the base. All right, basically base. All right, the best way I can explain this is you just cover up the negative and you evaluate the exponent, and then whatever your answer is, now you bring the negative down. Okay, so you kind of pretend like it's not there. What is 2 to the third power?
8.
It is 8, and now you just bring down your negative and you make it negative 8. Okay, so when it's not in parentheses, you evaluate the exponent just like normal, but the negative is not involved in that at all. And then you just bring it down in your answer. Okay? All right, so yeah, this is a good question. They're both negative 8, but they're negative 8 for a different reason. And you're going to see in the next slide that it actually does matter. Or maybe it's example 2. All right, but that negative being in or out of the parentheses does make a difference. Okay? All right, example 1. In example 1, I've given you 6 different expressions that we're going to write as powers. Okay, write the repeated factors as powers. We're doing 6 different ones. All right, so what I want you to do is write down all 6 of them. Go ahead and just write down all 6, and then of course leave space in between them so we can go back and work each one of them. You may right off the bat be able to look at these and know generally what we are about to do. Okay, but it's important that we talk about each one. Obviously, we have fractions, we have decimals, we have variables, we have mathematical symbols like pi. We have negatives that we need to look at. So we're going to try to touch on all of the different types of problems that you might see. The first thing we need to talk about is the operation. What do I mean by operation? Am I, in all of them as a whole, am I multiplying, adding, subtracting, or dividing? I am multiplying. That's what that dot is between each term. If I was adding, this does not work. Would you agree that there's a difference between -7 multiplied 3 times and -7 added 3 times? Isn't there a big difference? Okay, so with addition, it doesn't work. And you need to expect a problem like that either on your homework or a quiz or a test. And I'll show you more what I'm talking about when we get into the review time. But when you're adding, you can't write repeated factors or repeated numbers as exponents. It only works with multiplication. Okay? So when you see a repeated factor over and over again, you can write it as an exponent. The parentheses matter, and because the negative number is in parentheses, I can keep it in parentheses and write it as a power. -7 to the third power must be in parentheses, okay? Because what that means is that -7 is the repeated base over and over again, and that's what we see in the original problem, okay? All right, let's move across now to 1/3. All right, what do we see repeating? 1/3, how many times? 4, and because it's positive, I can just write 1/3 to the 4th power. I do not need parentheses. So what I see in the exponent section sometimes is people go like parentheses happy. All right, they start putting everything in parentheses. Well, they are purposeful for a reason. So sometimes you need them and sometimes you don't. You don't ever need them when it's a positive base, okay? You don't need them. All right, now let's go to our x's. Do we know what x equals? Nope, doesn't matter, okay? All we care about is how many times it repeats. How many times does it repeat, guys? 5, so what do you think? X to the 5th power. The exponent tells me how many times it repeats. All right, what do you notice that's different about the next one, moving across? You see what? Decimals and variables. So could I just raise it all to the 5th power? No, I can only work with the common bases. So 0.3 repeats how many times? 3. Okay. X repeats how many times? Twice. And we do know that a number being multiplied by a variable, which is what's happening here, can just be written next to each other. Just like we can write 2x, and I know that's 2 times x. Even though we have exponents, we do not need a dot in between the terms. We do not need parentheses. We can just write them together. So I will be taking off if you put a dot here. Like right here between the 2 terms, don't do that. All right, you don't need it. Okay, let's go down to the bottom left. All we're showing you is just now a different look at the same repeated multiplication. So how many times does pi repeat? 3. So how do you think you're going to write it? Pi to the 3rd power. I don't care what pi equals. I'm just writing the repeated multiplication as a power. And then I write r to the what power? No dot, no parentheses, just write them right next to each other. Okay? Now, let's look at this last one. That's awful similar to the first one in terms of like what the number is and how many times it repeats. All right? But there's something that's different about this one. What do you notice that's different, Josh?
All the 7s are 1 parentheses.
Okay, the 7s are inside the parentheses, and then you have the negative outside. What this is saying is that the negative is not connected to the repeated multiplication, meaning it's just -7 to the 3rd power without parentheses. Again, anytime I see no parentheses, I know that the base is repeating, but the negative is not connected to the base. All right, so that's kind of how it looks in reverse. All right, and we're going to look at this more again in the next example and how we would evaluate. All right, 3 examples today. Let's move on to example 2. You've got 4 problems. I want you to skip 2 lines in between them. So write them, skip 2 lines. You can write them next to each other like I did. All right, and then we are going to now evaluate. So we know the values, okay? So we can actually evaluate these expressions. Remember, we are not using calculators, all right? Using a calculator in this chapter would not require any mental effort at all. All you would be doing is punching in numbers to get an answer. So in order for us to actually learn these concepts, we can't use them, all right? So what you're going to see, especially on a quiz or a test, it's not a test on can you multiply, let's say, 1,300 times 65. All right, I'm not testing you on can you multiply huge numbers. You're not going to see huge exponents. I'm testing you on exponents, and can you evaluate them? Do you know the rules? Okay, does that make sense? All right, so we're going to keep the numbers small because we have no calculators, and I don't want to bog you down on, all the calculations. Let's look at the top left one. Here we go again with these negative bases. Okay, so remember, my base is the number that's being repeated. The parentheses make all the difference. If the base is negative and it's in parentheses, that means that the negative repeats. -2 times -2, 4 times. All right, now on your homework, I need you to show me this step. All right, and the reason why is because showing your work on your homework is you showing me that you did not use your calculator. Okay, so you need to show the steps. All right, now the repeated multiplication, I can do this. 2 times 2. Okay, let's just multiply the numbers, then we'll talk about the sign. What's 2 times 2? What's 4 times 2?
8.
What's 8 times 2? 16. So I know that my answer is 16. And now I can apply my even odd rule. So again, this is not a rule or a lesson on integers, but I do know that if there's an even number of negatives, my answer is what? Positive. If there's an odd number of negatives, my answer is negative. Can I give you a shortcut? If your exponent is even, it's positive answer. If your exponent is an odd number, when it's in parentheses, okay, it has to be in parentheses, but if your exponent's odd, it's going to be a negative answer. So I know it's positive 16. That only applies when the base is in parentheses. All right, so what do you notice that's different about the second one? No parentheses, which means, okay, that the negative is not factored in to you evaluating the exponent. That means that the negative is essentially outside, and I'm going 2 times 2, 4 times. Okay? So the negative is not connected to the base. It's there, but it's not connected. So again, what's 2 times itself? 4 times. It's going to be 16, and now I bring down my negative. All right, so going back to that first slide, remember when we got the same exact answer and you were like, it's -8 both times? Well, when it's an even exponent, that is going to change your answer, okay? So it's really important, parentheses or no parentheses, that you understand what's happening there. All right, this is not a trick question. So, again, every year when we're learning very difficult exponent rules, we sometimes see the easy ones and we think it's like a trick. Do you agree? All right, so don't overlook this. Like, it's just 12 squared. What's 12 squared? What's 12 squared, guys? 144. Okay, it's 12 times 12. All right, it's okay. It happens. Again, because we get into this, higher level thinking, and then it's hard for us to do the simple ones. But we know that's 12 times 12, which is 144. All right, last one. We have a negative fraction being raised to a power. So the parentheses matter. Are there parentheses?
Yes.
Which means what? That the negative is connected to the base. -1/6 times -1/6 times -1/6. Okay? I would definitely challenge you to write that repeated multiplication. All right, on a quiz or a test, when I know you don't have a calculator, that step will not be deducted. However, now, on your homework, you have to write it, okay? You have to write all your steps. But it's important because the more steps you skip, and I'm going to really kind of like focus on that on the next example, the more steps you skip, the more likely you are to make a mistake. All right? Now, multiplication, guys. What is 1 times 1 times 1? Multiplication. 1. It's okay. All right? What's 1 times 1 times 1? 1. Okay? Now, the bottom ones, denominators are going to be a little harder. This is not addition. I don't just bring over my 6. What is 6 times 6 times 6? 6 times 6 is 36. 36 times 6. There will be a few where you might need to do some work off to the side. Again, it's nothing crazy. No.
216.
Yes. 216. Is my answer positive or negative? Negative. It can be out front, in front of the fraction. It can be attached to numerator or denominator. It just needs to be in your answer. Okay? And I also know this because my exponent was odd. My answer would be negative. Okay? All right. Any questions there? Okay. Going on to example 3. All right, go ahead and write down these 4. Write down these 4. Okay? 3 plus 2 times 3 to the 4th. All right, write down all of them. I need you to skip like 3 or 4 lines in between them because, again, because we have no calculator, we're going to show all of our steps to hopefully avoid making any simple mistakes. All right? Again, order of operations, you might be able to do some of it in your head as mental math, but the more work you show, the less likely you are to make a mistake. And that's really what I come back to when I have students ask me, Miss Kinder, like how much work should I show? I say show as much as you can because that's your best chance at getting the answer right. Okay? Even I make mistakes when I do mental math. All right? So just finish writing these 4 down. Okay, 3 plus 2 times 3 to the 4. 3 to the 4, sorry. All right, before we do this, we must review PEMDAS. PEMDAS, let me write it in red. Okay, this would be very helpful for you to write in your notes. Please excuse my dear Aunt Sally. Okay, P. P stands for parentheses. Write it down if you don't remember. You do not have to write it down if you remember. Parentheses, or what does it mean? It means groupings. Okay, I need to do my groupings first. What does E stand for?
Exponents.
Exponents. What about M?
Multiplication.
D? Division. A?
Addition.
Addition, and S? Subtraction. And you guys know that multiply and divide goes together, left to right. So once I only have multiplication and division, I work left to right, and addition and subtraction work together, left to right. I don't say, oh, well, addition comes first, so I didn't. No. Once you're down to addition and subtraction, you just work from left to right. Okay? So there's our PEMDAS. Now let's come down and again follow order of operations. So sadly, I wish I could say that it's going to be different, but I can already predict on your test that this will not be 100% for every student that I have. Okay? And here's why. Because there's too many areas where you can make small mistakes, and they will happen. How do you avoid them? What did I just say? Show your work. Okay? You say, well, I can do that in my head. Honestly, I believe you. And on your test, you won't be deducted for not showing it, but the more work you show, the better chance you have. Okay? So here we go. All right, 3 plus 2 times 3 to the 4th. Order of operations says, what do I do first? Just tell me. Exponent. So I challenge you. And again, on your homework, you have to show these steps because that's how you're showing me you did not use your calculator. 3 to the 4th means 3 multiplied 4 times. Okay? So once I see it, guys, this helps me. I'm showing you what has helped me in the past get these answers right. 3 times 3 is 9. 9 times 3 is
27.
And now I can see 27 times 3. This might be something I do off to the side. Or 27 27 times 3 is 81. 3 plus 2 now times 81. Again, I'm showing this next step. Okay, so I've got my 81. So what do I do now? Do I do 3 plus 2 or 2 times 81?
2 times 81.
2 times 81. I must multiply. Okay, so can I give you a hint on mental math? Okay, this is the part you don't necessarily have to show. 2 times 8 is 16. 2 times 1 is 2, so 162. Okay, you can double each place value. All right, so that equals 3, yes, plus 162, which is 165. Couple places you can make a mistake, right? But step by step, it's nothing that you don't know how to do. You know how to do your basic multiplication. It's just getting the steps in the right order. All right, let's look at the next one. 3 to the third power minus 8 to the second power divided by 2. I want you to try to get to step 2. All right, that's all I'm going to give you for now. Try to get to step 2. And honestly, odds are once you get to step 2, you're going to know what to do to get to step 3 and to get to your answer. All right, I'm just going to kind of walk around, browse around, see how you guys are doing on your notes, and then we'll go over this. Okay, so we have to evaluate our exponents. 3 to the third power is what? Everybody write 27. Nobody wrote 9, right? Okay. So it's not 3 times 3. It's 3 to the third power. Now, negative 8 squared. Are there any parentheses here? No, there are no parentheses. So this is minus, what is 8 squared? 64. Okay, so again, that negative is not connected to my base. Divided by 2. So now negative 64 divided by 2. Let me give you a hint on the mental math. Anytime you are halving a number, you can take half of each digit. What is half of 6? 3. What is half of 4? 2. So it's 32. Okay? So these mental math tricks, guys, could definitely help you because we don't have a calculator to fall back on. All right? Now, 27 minus 32 we know is different signs. So subtract and take. Negative 5. All right? Any questions on that one? Okay, I know a lot of you guys actually got that right before we did it, so that's awesome. Great job. All right? Now let's look at this next one. What do you see here? Parentheses. But what makes it fall under your P category is that can you simplify this? What's in the parentheses? Could you simplify that? Kind of going back to what you said, Ethan, was, you know, like if you have numbers you're raising to a power, you can evaluate that. Okay, so yes. But first, inside the parentheses, I have to do what? Do the exponent. Okay, which there's a catch here. So I want you to go ahead and try to get to step 2. Try to get to step 2. Because of the way that it's written, it's going to be a certain answer. Okay, so we need to make sure we're all on the same page. Try to get to step 2. Okay, so negative 3 times, all right, so here's the question. Because negative 10 is not in parentheses, what does that mean? Is the negative connected?
No.
No. All I do is just bring it down, and now I evaluate 10 squared. What's 10 squared?
Negative 100.
Yes. So if the parentheses were there, it would have been positive 100, right? So that no parentheses thing, that affects my entire answer. No parentheses, that means I bring my negative down and I evaluate the exponent, plus 70. All right, so I know the difference between 100 and 70. How many more do I need to get to 100 from 70? 30, so that's the difference, okay? But is it going to be positive or negative? Because what is bigger? 100, right? And guys, common sense wise, so I'm subtracting negative 100 plus 70. Common sense tells me if I owe someone $100 and I pay them back 70, are they like, oh yeah, you're good? You don't owe me any more money. No, right? So when you're in debt, you have to pay back all of it. So negative 100 plus 70 is negative 30. So what's negative 100 plus 70 again? Just remind me. What was it? Negative 30. So what's negative 3 times negative 30?
90.
Yes, 90. Good job, guys. All right, last but not least, these bars I have not seen in a long time. Let me just make them a little more defined. Anybody remember what those bars are called?
Absolute value.
Absolute value, which means once I simplify what's inside these bars, I'm going to take the absolute value of that number. All right, so go ahead and try to get to the next step. Leave it inside the bars until we have everything simplified. Try to get to step 2. Okay? Okay, let me ask you this. Am I putting -3 in parentheses?
No.
No, because there's no parentheses. That's like saying, okay, just do 3 to the third and then bring down your negative. Okay? So what's 3 to the third power?
27.
27, and then I make it negative. Okay? All right, this is not addition. What is -27 divided by 27?
-1.
It's not 0. Yes, it is -1. Very good. And now I take the absolute value, which means the number without the sign, which is 1. All right. Great job, guys. If you understand that, that's everything you need to know for 8.1.